Hello everyone. In this video, we are going to see how to use an online Arduino simulator to build a basic circuit and run it. If you are new to IoT or didn't have the hardware to get started with, you can start using the simulator and build some simple projects. And if you got comfortable enough, you can go ahead and purchase the necessary hardware for building real life projects. And there are many online simulators available for Arduino and other boards, but I find this particular website very easier to play around with. And here you can see that you can choose a range of boards, and also they had given various projects that you can build with these boards, and these are some interesting games that you can try. And it shows you the possibility on what all you can do with using just the Arduino, right? So basically, I'm making this video for a peer assignment. Actually, it's part of the Coursera course named Interfacing with Arduino Circuits, and it's an peer assignment that you need to build either using the hardware or using a simulator and submit. So I'm basically making this video for that particular assignment, but you can still go ahead with this video because I will be explaining you from the basics on how to connect the components to the Arduino as well as the coding part. So the first circuit they ask to build is using two push switches and an LED bulb. So the problem statement is if we press either one of the switches, the LED should turn on. So it seems very easy, right? So let's go ahead. I'm building this using Arduino Uno. Um, it's because it's an cheapest board that you can afford in a budget price. And for most of the simple projects, you can go ahead with the Arduino Uno. You can opt for Meha if your project has various and components to connect with. But for beginners, Arduino Uno is more than enough. They had actually provided various kinds of interesting things that you can do using the Arduino boards here. But here we are going to build from the scratch. So let me select the Arduino Uno, and here we have our Arduino board, and the use of this interface is very straightforward. Let me move this around a bit, and here you can choose various components from LEDs, push buttons to various other sensors and displays they provide. You can play around with each of these. For now, let me show you a simple example of a glowing LED, which is very simple, right? So as all we had played around with the LED bulb at a certain part in our lives. So here you can choose the color of the LED. I am sticking around with the default red color LED, and here the one here, the shortest terminal is the negative that should be connected to the ground, and the one that is bended or usually that is a long is the positive end that has to be connected to the 5 volt. So if you played around with the batteries, you know that LED requires very least amount of voltage, and you can't directly connect them to the power source. Otherwise, the LED will go blank or it will be dead. So in that case, we need an resistor that controls the amount of current that flows through the LEDs, kind of like an restriction. So let's get in an resistor as well, and here we can specify an resistance value. So let me give 220 ohms. If you wonder why 220 ohms, actually I too don't have an idea on what it is. Actually, if you are an electronic student, you might know. Basically, I had found this on an article somewhere like this, which is an Arduino's official page. So just remember that when it comes to LED, use a resistor of minimum 220 ohms. And let us connect the positive end to the 5 volt supply and the negative to the resistor, and then it should be connected back to the ground. You may wonder like we can connect the resistor on the positive terminal too, and I believe that it works, but I am following the circuit diagram that they had provided in the Arduino's official documentation. Mostly they had connected the resistor to the negative terminal, so I am following the same terminologies. As the bulb is positive terminal is connected to the voltage and the negative terminal is connected to the ground along with an resistor. Now if we run the simulation, we hope to see the LED glow. So let's run the simulation. Yep, you can see here that the bulb glows. It's very simple, right? We can directly glow an LED just by connecting it to a battery, right? For that, we don't need such an expensive logical board. We have this for some controlling purposes on to instead when to glow this LED or not, right? So let's disconnect these things. And in here, if you wanted to remove something, just click on that and click the delete button. So as we had seen how to connect an LED directly to the voltage and the ground and make it glow, let us bring in a switch or push button and let's see how to use that. If you are unfamiliar with the push button, basically here the left two terminals and the right two terminals are connected together internally. And what happens when we press the button is bottom and the top terminals gets connected. Um, Though it might be confusing, it will be very evident when we use the LED here. So let me connect the left bottom terminal to the voltage and let me move this a bit. And before connecting the positive terminal to the switch, as we seen before, we need an resistor of the magical value 220 ohms. So let me connect it to the positive terminal of the LED and to the top left terminal of the switch. The negative terminal can be directly connected to the ground. So what we expect now is even if the Arduino board is on, when we run the simulation, the LED shouldn't glow because internally the top two terminals and the bottom two terminals are isolated or it's open. Only when we press the switch, it will be connected and the LED glows. So it's how to use and switch in the Arduino, but it doesn't involve any coding, right? But as I had said at the start of the video, we will be using some coding, even though it's not necessary for this particular assignment. You can submit this directly by using another switch. Let me introduce you to the concept of programming here. So let's get to the coding part. So basically, I will show you a simple Arduino code that will show you whenever the button is pressed. It will show you that something like the button is pressed. I had a similar setup here. I had connected the bottom left terminal to the 5 volt, and instead of connecting it to the LED, here I will be connecting it to the digital pin, one of the digital pins. I'm using the digital pin 2. As you can see here, these are the digital pins and these are the analog pins in an Arduino Uno board. And the subtle thing that you need to notice here is that the digital pins in the Arduino are so sensitive than the LED, and even a small leakage current that happens to flow from the bottom to the top terminals will be read as a high voltage in these. So in order to prevent that, we will be having a pull down network. Let's have an resistor of 10 kilo ohm and let me connect it to the ground. So basically what it does is when the switch is not pressed or when the circuit is open, if any leakage current happens to flow to the top terminal, it will pull it immediately to the ground, so we don't read a high voltage in the terminal accidentally or by mistake. So that's why we are having an pull down network here. So let's get to the coding. we had a predefined setup and the loop functions that are by default for all of the Arduino programs that you write. Let's get to these later. The first thing that you had to do with the coding part is you need to define the pins that are connected to the Arduino boards. Here we had connected the switch to the digital pin 3, right? We need to define that. Basically, if you are familiar with the programming terminologies, if a variable that doesn't changes, we will define that as a constant, because the digital pin 3 that has been connected to the switch remains the same, and we won't be doing any alterations throughout the execution of the program, right? So basically we define all the connections as a constant integer. And here the let's name the variable as the button pin. Here the button pin is 2 because we are using a digital pin 2 here. And later that inside the setup function you need to define all the input output pins as well as the code mm, that needs to be executed when the Arduino is turned on. So here we are using the digital pin 2 as an input to the circuit. So in that case we will be defining the pin mode button pin 2 as an input pin. So after that we could be printing the state of the button, right, whether it is pressed or not. So for that we need an serial monitor. Serial dot begin, let's use an bit rate of 9600. We are done with the setup. After that inside the loop is where our main code runs continuously, and in here we need to be reading the state of this particular digital pin, whether it is high or low. When we press the button it will be high, and when it isn't present it should be on default 0. So let's also define it here. This variable isn't constant because it will be changing throughout the execution, right? So we shouldn't define it as constant, and let's define the variable name as button state is equal to 0. Here we are using the boolean values. Here low means 0 and high means 1. By default it should be on the low state, so we are using 0 here. And in the loop let's update the value, that is the button state. Here the button state is, here we are reading from the digital pin, and the digital pin is the button pin. And what we expect to be stored in this button state variable is when the button is pressed, then the, let me type the typo here. So when we press the button, we expect the value in the button state variable to be 1, and if not it should be 0 by default. And let's check whether the button is pressed. If the button state is equal to, which is an equivalence checking operator in C, is high, you can use 1 2 here, but we are sticking with the terminologies of high and low in this case of Arduino. And if we read an high state in the button state variable, what we expect to do is we could be printing it into the serial monitor. We will be printing like the button is pressed. Sorry for the typo again. So let's try to compile and run our program here. It's actually compiling and there are no errors. So when we press the button, we can see that it's printing that the button is pressed. Though we had pressed the button only once, we are getting these many print statements. It's because the loop is running at a millisecond interval, and so that we need to introduce a delay like 200 millisecond. This should work fine. So now when I press the button, as you can see the button is pressed. When I press the button again, the button is pressed. So it makes sense, right? So it's how you could be using the uh, program. So in order to bring in the LED, let me bring in the LED and connect it to one of the digital pins. Here I could be connecting the LED to the positive terminal to the digital pin 13, but as we know that we need an resistor, though it might work fine with the simulator even if you don't use any kind of resistor, but in practice if you are dealing with the hardware, it's good to use the resistor to prevent your LED from blowing out. So yep, and the negative terminal can be directly connected to the ground. As the ground isn't visible here, I'm using the ground here. You can use the ground pin that's present at the bottom as well. So as I connected here, I need to define here as well. Here the const int LED pin, I have connected it to the digital pin 13, and basically here the pin mode LED pin, it's actually an output pin because we will be passing the voltage to the LED from the digital pin 13 based on the state of the button, right? So in here I will be reading the LED state as well. At the start the LED state should be 0. LED state is equal to 0, and during the execution I will be reading its state. LED state is equal to, I shouldn't be reading that, I could be making it high or low. So when the button state is high, then I will be digital writing high to the LED pin. Actually, I don't need the state variable here because I could be directly passing the voltage to the pin. When the button is pressed, it will put the digital pin on the high voltage and the LED will glow. So if not, if the button isn't in the pressed state, then we will be passing a low value to the LED pin. Here the LED pin should be on high, and here the LED pin should be on low. So this should does the thing. Let us check. Yep, it has compiled successfully, and as you can see that the bulb or the LED isn't glowing. But if I press the button, it's glowing, and we are printing that the button is pressed. When the button is pressed, the LED is glowing, and we are getting a continuous print statement that our button is being pressed. And when I release the button, it's going off. So basically in the assignment, we are asked to use two uh, switches or the buttons, right? So in that case, it's very simple. Basically, I will bring in an additional push button, and I will be connecting it to the pull down network, and then let me move this down a bit, and then to the positive. I'm making an direct connections here, and here I'm connecting it to the digital pin 3. So let me redefine a button pin 1 and button pin 2, and it's on the digital pin 3, and let me redefine it. Button pin 1 and button pin 2 are the inputs, and I will be reading the states from both the buttons. Button pin 1 state represents the state of the button 1 and the button pin state 2 represents the state of the button 2. I need to redefine the initial state as well. Initially, the state of both the buttons 1 and 2 will be 0. And here, we will be using an additional conditional statement, that is, if either the button state 1 and the button state 2 is on, state 2 equal to high, I could be turning on the LED, that is putting the LED pin on the high. If not, I could be putting it on the low state. So let's try to compile this. We have an error here. Yep, instead of on, I had used not. So now the error could be fine. Yep, it's running fine. So when I press the button 1, it closes, and when I press the button 2, it closes as well. So if you wanted some more kind of an control, then you can be like use nested things, right? So let me copy this here and paste it here. What it basically does here is that it will be checking the button 1 state, and whether if it's high, then it will turn on the LED and print that button 1 is pressed. If not, it will go on to check the button uh, 2 state. If it's high, then it will print like the button 2 is pressed and again put the LED to high. And if both the conditions fails, well, in that case, we could be putting the LED on a low state. So let me rerun it. So now when I press the button 1, you can see that the button 1 is pressed and the LED is glowing. When I press the second button, you can see that um, actually I expect to see button 2 is pressed. Mm, let me button 1 state and so yep, the code is just fine. I had made some modifications on the circuit. Basically, before we had just connected these um, pull down network and the voltage to that of the uh, button 1. So the problem is that when we press the button 2, the voltage also passes to the button 1 and we are reading the button state 1 first. So this statement gets executed even when the button 2 is pressed. So in order to overcome that, I had implemented a separate pull down network for the button 1 and button 2 and separate voltage lines as well. So now it should work fine. So when I press the button 1, you can see that button 1 is pressed and the LED is glowing. And when I press the button 2 is pressed and the LED is glowing. So that's all for this video. You can directly connect the switches to the ground and the voltage and then directly to the LED for this assignment, or you can use the coding part as well. But for this particular module 1 assignment, it's enough to connect the switches and the LEDs directly instead of making use of the digital pins and all the code. But this is just for your educational purpose and to inform you about how to use the coding part in order to utilize the Arduino. After all, we are using an Arduino circuit in order to check some conditions and do some operations based on that, right? So that's all for this video. So let me see whether I can continue this series and also upload any new videos on other topics as well.